Right, and he says scientism claims that it has cognitive superiority over all other fields of knowledge and study. So he asked the question, but what if there are things that we can know with greater certainty, right? And in different ways than we know the claims of the hard sciences. And so in this chapter, as I mentioned, he wants to briefly think with us about three kinds of claims: logic and math, our personal conscious states, and the moral law, right? To show us that the emperor of scientism has truly no clothes. And so that's what he wants us to see in this particular chapter.
Right. So we'll get a little bit more heady here in chapter 7. All right. Well, what about this whole logic and math thing? We can know this better than we can know science. Well, he's already mentioned the importance of the laws of logic and of the basics of mathematics. But what is it about these areas of knowledge that set them above science? They have two characteristics that are worth noting. First, the law of logic and basic mathematics are known in an a priori manner, by direct rational institution or awareness, without appealing to sense experience to justify them, right? So again, how is this table in front of me made up of? Well, of wood and plastic. Okay, well, what are those? Well, I have to develop tools to disassemble and to break down these parts into even smaller components, and then I have to see what their structure style is, and then I find just a bunch of empty space, but within that empty space I find these little small particles, and I'm going to label them, and then what are they made up of? Well, then I have to build a big little slingshot around pretty much all of China, and then we'll maybe be able to see what those things are made of.
Or even worse, the table is just a hologram.
Right.
And so notice our cognitive or our sense perception sees a table, but it's really a hologram. And so but we think it's a table. But we can't make a mistake about 2 plus 2 equals 4.
Right.
Exactly. It's 4, right? So there's no hologram, right? There's no confusion. There's no, oops, I made a mistake by my experience, right? Or perception. And so that's the point that he's trying to make here, right?
Right.
Mathematics, laws of logic are a priori, and we know them by direct rational intuition or awareness. And that seems to be, he's going to argue, superior to sense perception.
Right. We can just rationally see that they're basic laws of logic and math and they're true. Then we can move on. That's it. That's all you have to do. That's how easy math is. For those people that claim that they're not math people, it's just the basic underpinnings of all reality for you.
And so he goes on to say that by contrast, then the theories and laws of science are in one way or another known in an a posteriori fashion. Right? That's the kind of what we were getting at there, right? By our sense experience, eventually requiring appeal to our observation and our sensual perceptions and that sort of thing. And so for any set of observational data, there's always more than one law or theory consistent with those data. And so he's getting at here what the philosophers of science call the underdetermination of theory by data, right? In other words, your observation of something, you make a theory about it, a scientific theory, right? But you can have a number of scientific theories that meet that same observation, right? And so for any set of observational data, right, we make an observation. He says there is always more than one law or theory consistent with that data. So we see something happen, but there are multiple explanations, even scientific explanations, right? And so he says it's generally, though not universally agreed, that greater rational certainty is available for a priori truths than for a posteriori truths. And so that's the first point he wants to make. This distinction between a priori, right, where we know by rational intuition something is the case, versus a posteriori, where we know by our sense perceptions. And in general, right, most folks would agree that the rational certainty of a priori truths are greater than a posteriori truths. And yet science is based mostly with regard to observational data on a posteriori truths.
Right.
And so math and logic seem to be superior, we might say, and give us knowledge over and above science.
Maybe that's just a difference. Maybe they're just slightly ahead in that area. Well, he's going to actually give us a second one. So the second characteristic of truth in logic and mathematics is that they are true. They are necessary truths. It's impossible for them to be false. Wow, okay, that's pretty impressive. But by contrast, scientific truths are contingent. Even if a scientific principle is true, it could have been false. And again, my shelves over my shoulder are strewn with a litany of sci-fi books that postulate, well, what if this was the case? And, what if science doesn't quite work like that when we're exposed to really fast speeds or really high gravity, or what, we go back in time and it quite wasn't like that. So it could have been something that it isn't. But something like 2 plus 2 is always going to be 4. It always has to be 4. It's always impossible for it to be anything other than 4. So if it's possible, for example, to imagine a world with different laws of nature, then we're unable to get there. And again, with even in the comic book world, there still has to be, you as the reader have to draw some inference to it. There has to be a way for you to relate to it. And you might be able to believe that Superman can fly, but if he's doing math that doesn't comport with what your understanding of as something as simple as 2 plus 2 equals 4, then you have no frame of reference at any point in time there, and that world doesn't operate well. So flying Superman, good. Clark Kent making a mistake on the blackboard for a math test, entirely possible. Right.
Yeah. All right. So that's the second one. So first, this distinction between a priori and a posteriori, gaining some knowledge. And then secondly, the distinction between necessary truths and truths that are contingent. And logic and math give us necessary truths. It's impossible for them to be false. Whereas scientific truths, since they're based on nature and our observations, which can change, right, are contingent. And that means that they didn't have to be the way that they are. So that's one non-scientific source of knowledge, actually two, right? Mathematics and logic that are not scientific.